Hello, future engineers. This is part 4 on plane trusses, and we apply combinations of method of sections and joints whenever deemed necessary. So determine the forces in members BC, FG, and BJ of the loaded symmetrical truss. Are the results affected by the statical indeterminacy of the supports at the base? So by looking at the figure, these are the required member forces BC, FG, and BJ. So the statical indeterminacy of the supports cannot affect the results because we don't compute the reactions at the supports. We consider the sectioning shown like that, so that there will be 4 members cut, and we indicate the required forces with red and not required forces with green. So considering the forces above this cutting section, we set moment at F0 and counterclockwise positive. So we have FBC times 12, then 200 passes to F. So minus 300 times 6. So therefore from here we can solve FBC equals 150 pounds tension. Then we set moment C0 to solve for FG, this time clockwise positive. So we have equals FFG times 12, then plus 300 times 6. Then we can compute FFG. It is equal to negative, so negative 150 pounds compression. For FBJ, since we already found this, so we have to introduce another cutting section and section 2-2, and we consider forces above this cutting section, and we put the values of the calculated forces in the preceding solution. And this is FBJ. Since this is 6 feet, so this angle is 45 degrees. So therefore, we have another member cut, which is GJ. And these two forces meet at G. This is known, so therefore we set moment G0. There are two components of BJ, namely horizontal and vertical. Both these components are counterclockwise about G, so let's consider counterclockwise positive. Let's begin with FBJ cosine 45, the horizontal component, times 6. Then the vertical component is FBJ plus FBJ sine 45, also times 6. Distance to G is 6. Then plus 150 times 12. Then minus 200 times 6. Take note, we set moment G0. Then minus 300 times 6 plus 6, so 300 times 12. So from there, only FBJ is the unknown. We can solve FBJ equal to 353.6 pounds. It is positive, so it is tension member. The hinge frames ACE and DFB are connected by two hinge bars AB and CD which cross without being connected. Compute the force in AB. So meaning to say, this is not a pin, so they just cross, but they are not connected. This is not a joint. So the base is indeterminate, but we can still manage to solve this. So we will call the reactions FV here, and here downward is a V. Then FH and EH. Then we consider the whole system. So we set moment F0 to solve for ISA V. So counterclockwise positive, this is equal to ISA V times 8. then minus 10 times 6, that's 6. So from there, we can solve E sub V equals 7.5 kilonewtons downward. So we introduce this cutting section, 1, 1, and we consider forces to the left. Although we have an unknown EH here, it doesn't matter because we extend the line of action of CD to find the point where it crosses so that EH and CD will not be involved in the moment equation. So these are the unknown forces, CD and the cut members, CD and AB. Now, since this is 5 and this distance is 8, so that means the horizontal distance between D and F is 1.5, and the horizontal distance between E and A is also 1.5. So that 1.5 plus 5 plus 1.5 is 8. Or 5 minus 2 is 3 divided by 2, so 1.5. So horizontal distance between B and D is also 1.5. Between A and C is also 1.5. So let's extend the line of action. Let's call that point O. And let's call the distance of O horizontally from E as X. Then by similar triangles, X plus 3 as to 4 equals X plus 5 plus 1.5 is 6.5, X plus 6.5 as to 6. So cross multiply 6x plus 18 equals 4x plus 26. So 26 minus 18 is 8, divided by 2 is 4. So x is 4. Then we set moment O 0, but let's solve for the angle here. Angle that AB makes with the horizontal is arctan of 2. 6 minus 4 is 2. This is 2 meters over 3.5. 3.5 is 5 minus horizontal distance between B and D, which is 1.5. So arctan of 2 over 3.5 is equal to 29.745 degrees. Then we set moment O 0. Clockwise positive, there are two components of AB. FAB cosine 29.745 horizontal, and its moment arm is 6. So equals FAB cosine 29.745 degrees times 6, clockwise, about O. The vertical component is FAB sine of 29.745. It is also clockwise. The moment arm is X, which is 4 plus 1.5, so 5.5. So plus FAB sine of 29.745 times 5.5. Then plus EV, which is 7.5 times X, which is 4. So 7.5 times 4. Then that's all, because we only consider forces to the left of this section 1 plus 1. So from here, we can now solve FAB. FAB is 3.779 kilonewtons. It is negative, so it is compression. Determine the force in member BE of the loaded truss. So this is member BE. So we have to analyze this well because the horizontal distance into B and E is not known. So study the angles. So there's no inclined load, so horizontal reaction at A is 0. And we will call the vertical reactions as AV and at D R sub D. So 45 degrees, 15 degrees, so that means this is 30 degrees. So this vertical distance, because this is 30 degrees, tangent of 30 degrees is 12 over this distance. Therefore, this distance is 12 divided by tangent 30 degrees. 12 divided by tangent 30 degrees, use your calculator there, is equal to 12 square root of 3 feet. Then, because this is 45 degrees, if we call this distance, horizontal distance between E and C as X, so that means this is 12 plus X. the vertical distance must also be 12 plus x because the angle is 45 degrees. So that's also 12 plus x. Then in this triangle, the right triangle, horizontal, vertical, tangent of 15 degrees is x over this distance. So again, tangent of 15 degrees is x over this distance. Therefore, this distance is x divided by tangent of 15 degrees. So from the figure, x divided by tangent 15 plus 12 plus x equals 12 square root of 3. So that we can solve for x. So solving for x is 12 square root of 3 minus 12 divided by quantity 1 over tangent 15 plus 1. So x is 1.8564 feet. Therefore, the horizontal distance of load L from A is 12 plus 1.854. So by the way, tangent theta is x over tangent 15, 1.8564 over tangent 15 divided by 16 minus x. So this horizontal distance is 16 minus x. 16 minus 1.8564. So theta can now be solved. 26.098 degrees, the angle that BE makes with the horizontal. And we need that. So this is also theta from the horizontal. So this distance is equal to 12 plus x. So 13.8564. While the distance of the load 2L from A is 12 plus 16 plus 12 minus 13.8564. This is also 13.8564. 12 plus x. So that's 26.1436. Then we set moment A0, summation moment A0 or moment A0, counterclockwise positive. So we have RD times 40, 12 plus 16 plus 12. Then minus L times 13.8564 minus 2L times 26.1436. Then RD can now be computed in terms of L equals 1.6536 L. Having found RD, then we cut section through this center panel, and so that these two forces, horizontal forces, are not involved, then our equation would be R vertical equals 0. So that these two green forces will have no component vertically. So the vertical component of FBE is FBE sine theta. So equals FBE sine of 26.098 degrees positive upward plus RD, which is 1.6536 L, then minus 2L. We consider forces to the right of section 1-1. So minus 2L. Therefore, we can now solve FBE. 2L minus 1.6536 L divided by sine 26.098. So FBE is equal to 0.787 for L tension. Determine the force in members DJ and EJ of the loaded truss. So this is DJ and this is EJ. Look the symmetry of the loading, geometric symmetry, and the geometry of the truss. So we use that so that we can conclude that FCD equals FDE by symmetry, and also CJ is equal to EJ by symmetry. In fact, JK is equal to GI, and so on and so forth. So by symmetry of the loading, the total load is 1, 2, 3, 4, 5 plus 0.5 plus 0.5, so 6L. Therefore, there's no inclined load. Therefore, the vertical reactions at A and G equal to 3L each. So horizontal 0 at A, then that's 3L. That is also 3L. There's no need to set moment at A0, then solve for the reactions because of symmetry, geometric symmetry of the truss plus the loadings. So we compute first the angle that CD and DE make with the horizontal. It is arctan of 0.5, vertical distance 0.5 over horizontal distance 8. So tangent theta CD equals tangent of theta DE equals 0.5 over 8. So theta CD equals theta DE equals 3.576 degrees. Then we cut this section 1, 1. Let's consider forces to the left. Then the members involved are CD, CJ, and JK. Then by principle of transmissibility of a force, we move CD to D. There are two components, but the vertical component passes through J. We plan to set moment J0 because these two members meet at J so that they are not involved. So this is FCD cosine of 3.576 degrees. The other component, the vertical, is just shown but not named because it has no moment about J. So moment J0, clockwise positive. So F equals FCD cosine 3.576 degrees times 10. This is 10 meters, distance length of DJ because 8 plus 1.5 plus 0.5 is 10. Then plus 3L, this 3L here, times quantity 8 plus 8 plus 8, 24. Then minus L times 8 minus this L times 16. Then minus this L over 2 times 24. So from there we can solve FCD. It is equal to negative 3.607 L. Then let's isolate joint D and draw the FBD. So obviously FDE equals FCD, but let's still show that they are equal by setting RDH 0, or the horizontal component of resultant at J0. So equals FDE cosine 3.576 degrees minus quantity negative 3.607 L cosine of 3.576. So cancel cosine 3.576, then FDE is also negative 3.607 L as mentioned earlier. Then summation, we set RD vertical 0, vertical component of resultant at D0, considering downward positive. So we have FDJ equals FDJ. Since these two are equal, so plus 2 times negative 3.607 L sine of 3.576, the vertical component of each, then times 2 because they are equal. So FDJ is positive 0.4500 L, and it is positive, so tension. Finally, as mentioned earlier, CJ is equal to EJ. EJ is required, but by symmetry they are equal. So we don't need to solve for EJ. We'll just solve for CJ. The angle that CJ makes with the vertical is arctan of 8 over 9.5. 8 plus 1.5 is 9.5. So this is 9.5. This is 8. So arctan of 8 over 9.5. Use your calculator there. I will just label the angle. 40.101 degrees. And since in this section here, considering forces to the left, JK is not yet involved, so the best way, because we found already CD, is set R vertical 0. Resultant or summation forces Y0, considering all forces to the left. So we have FCD, which is negative. It is upwards, but its sign is negative, negative 3 point. So we'll consider 3L first. Then plus FCD, which is plus negative 3.607 L sine of 3.576, the vertical component. Then minus, because this is downward, FCJ cosine of 40.101 degrees, the vertical component of FCJ. Then minus L over 2. So minus L, minus L, minus L over 2. So take note that FCJ is the only unknown here. Solving for FCJ, transpose to the left, then compute the values to the right. FCJ is 0.3595 L. So therefore, because FCJ is equal to FEJ, then FEJ is also 0.3595 L tension. And that's it. Determine the forces in members DE, EI, FI, and HI of the arc roof truss. So this is the figure. Then since there's no inclined load, the horizontal component of reaction at G is again 0. And because of the symmetry of the loading and the figure, the total load is 100 plus 75 plus 75, 250 plus 25 plus 25, 300. So therefore, each vertical reaction here would be 300 over 2 or 150 kilonewtons as shown. So 0 and 150 kilonewtons each. There's no need to sum up moments about the other support by symmetry. So first, let's solve DE by introducing this section here, 1, 1, and considering forces to the right. So we put the forces in tension for the cut members, red for the required, then green for the not required. Then we compute the angle that DE makes with the horizontal arctan of 3 meters over 6 plus 4, so 10, arctan of 3 over 10. So theta DE is arctan of 0.3 or 16.699 degrees. There's no need to show that because I mentioned it. So we sum up moments about I, or moment I is 0. The horizontal component is counterclockwise, so let's consider counterclockwise positive. The horizontal component of FDE is FDE cosine of 16.699 degrees, and the moment arm is 4 meters. So again, the horizontal component is FDE cosine of 16.699, then the moment arm is 4. So FDE cosine of 16.699 degrees times 4. The vertical component is also counterclockwise, so plus FDE sine of 16.699, the moment arm is 6 meters. Upward, then 6 meters. Then plus 150, the moment arm is 4 plus 6 plus 6 is 16. 150 times 16. Then minus 75 times 6. Then minus 25 times 12, 6 plus 6. So from there, we can now solve FDE using your calculator. It is negative, so it is compression, 297.0 kilonewtons compression. Then having found FDE, next target is EI, so we proceed to joint E. So these are the unknown forces. This is the required force EI. Then we need the angle that EF makes with the horizontal as well as EI. By symmetry, these angles are equal. Theta EI equals theta EF. And the angle is arctan of 4 over 6. 4 vertical, 6 horizontal. 4 vertical, 6 horizontal. And that is 33.69 degrees. So we set RE horizontal or horizontal component of resultant at E0. So FEF rightward, so this is taken positive. FEF cosine of 33.69 degrees. Then FEI is to the left, so minus FEI cosine of 33.69 degrees also, the horizontal component. Then minus FDE, so minus negative 297 because the sign of FD is negative, cosine of 16.699 degrees. That's the horizontal component of FD. Simplifying, FEF cosine 33.69 degrees minus FEI cosine 33.69 degrees equals negative 284.47. Call that equation 1. Then RE vertical equals 0. Vertical component of resultant is 0. So this is upward FDE, so equals negative 297 sine of 16.699, it's the vertical component of FDE. Then minus FEF sine of 33.69 minus 75, then minus FEF sine of 33.69 degrees. Then FEI is also downward, so minus FEI sine of 33.69 degrees. So transposing these two to the left, so we have FEF sine 33.69 plus FEI sine of 33.69 equals negative 297 sine 16.699 minus 75, and that is negative 160.34, equation 2. So solving equations 1 and 2 by elimination, substitution, or whatever convenient method you want, or by determinant, or by Kramer's rule, or any available method, then we have FEF equals negative 315.47 kilonewton. So it is compression, but that's not required. We need FEI. FEI is equal to 26.42 kilonewtons. So positive, so it is tension. Next is Fi, which is this one. We cannot find that yet because we do not know Fg. So HI. Observe that joint H here, this HI and GH are collinear, and there's this oblique member FH or HF. This is a zero force member by case 2. So that's 0. So if that is 0, because HI and GH are collinear, then the force in GH is also the force in HI. You should be quick with that because there are so many problems we encountered, then you should know the principles already. So FGH is equal to HI. We need to solve for FGH, so we isolate this joint G here. The angle that GH makes with the horizontal is arctan of 14 over horizontal distance 6 plus 6 plus 4, 16. Arctan of 14 over 16 is, I'll just label it, 41.186 degrees. While the angle that FG makes with the vertical is arctan of 4 over 14, and that is 15.945 degrees. So at joint G, these are the unknowns, method of joints. I make GH red because it is equal to HI also. Whatever is the force in GH, that's the force in HI, which is required. So RG horizontal equals 0, or the horizontal component of resultant at G0, or summation forces horizontal 0, considering leftward positive because all these forces are leftward. So FGH cosine of 41.186 degrees, then plus FFG sine of 15.945 degrees. So those are the forces involved because this is 0. So we express FFG in terms of FGH. So it is negative cosine 41.186 over sine 15.945 degrees. So FFG is negative 2.7395 FGH. Then RG vertical, or the vertical component of resultant at G0. So vertical component of FGH is FGH sine of 41.186 degrees plus FG cosine of 15.945 degrees, then plus 150. So replacing FFG with negative 2.7395 FGH, which is this, so cosine 15.945 degrees plus 150. Now we can now solve FGH, the only unknown in this case. So FGH is equal to 75.93 kilonewtons. It is positive, so it is tension. Since, as mentioned earlier, FGH is FHI, so FHI is 75.93 kilonewtons tension. Then the value of FFG, because we need that, we isolate joint F to solve for Fi. So FFG is negative 2.7395 of 75.93. So FFG is compression, or negative 208.0 kilonewtons. Finally, we isolate joint F. Let's draw the figure, FBD. So this is Fi required, and this FFG is also known downward. And take note, the angles are already found. FEF is also found, negative 315.47. So to solve for FFI, set RF horizontal 0, or the horizontal component at F0, or simply summation forces horizontal 0. So let's begin with FFG because it is rightward, but it is negative. So equals negative 208 sine of 15.945, the horizontal component of FFG, negative 208 sine of 15.945, minus FFI to the left, then minus FEF, so minus negative 315.47 cosine of 33.69, the angle that EF makes with horizontal. So that's it. We can now solve FFI. So FFI is equal to 205.3 kilonewtons. It is positive, so it is tension. So that's it.